Okay, so last time we looked at using standard form to represent large numbers. Today we're going to try and use it to represent small numbers, numbers less than 1. So what did we say about standard form? Well, we looked at the fact that standard form was a way to represent numbers with two parts. And I've expressed it here as a times 10 to the power of n, where a is some number between 1 and 10. It can't actually be 10, so strictly we should say greater than or equal to 1 or less than 10, times 10 to some power. So here n is that power of 10. So we always need a number between 1 and 10 times 10 to some power. And the number that we've got to look at is 0.000213. So how would we express that number in standard form? Well, the first thing we'll do, similar to last time, is we'll look at this part of the number, the 2, 1, the 3. And we'll write that down here. 2, 1, 3. So we'll ignore all these leading zeros and just take the 2, 1, 3 from the number. Now clearly 2, 1, 3 is not a number between 1 and 10. So we need to put a decimal point in to make 2.13. That will give us our number that's between 1 and 10. So we've found our a, we need 2.13. Now we've now got to times that, to multiply that by 10 to some power. But you might already be thinking, well, hang on a minute, if we do 2.13 times just 110, surely that's going to give us 21.3. Now that's bigger than our starting 2.13. That's not going to get back to 0.000213. If we times by 10 again, it's going to get worse, because we're going to be left with 213. So the method we used last time is not going to work here. What we need to be doing instead, effectively, is dividing by 10. Because if I take 2.13 and I divide by 10, we're going to get 0.213. Well, that looks like it's on the right lines, in the right direction, because 0.213 is smaller than 2.13. If I took that 0.213 and divided by 10 again, we'd get 0.0213. So you should be able to convince yourself that if we keep dividing by 10, eventually we'd get back to this 0.000213. Okay, the trouble is, that doesn't look like what we've written here. It doesn't look like a times 10 to the power of something. So what we need to do is work out a way that we can express those dividing by 10s as a multiply by 10 of some power. Let's get rid of this. So we've got our 2.13, our starting number, and we're saying that we want times 10 to some power, but in a way that really is going to be like dividing. Okay, so what can we do? Well, when we did our index laws, we learned that, if we just write over here for a minute, we learned that 10 to the power of minus 1 was the same thing as 1 divided by 10. Or 10 to the power of minus 2 was the same as 1 divided by 10 to the power of 2. And 10 to the power of minus 3 was equal to 1 over 10 to the power of 3. Okay, so what do these work out to be? Well, a tenth is done already. This is going to be 1 over 10 squared, which is 100, 100th. And this is going to be 1 over 10 cubed, 10 times 10 times 10. So 1,000 on the denominator, which gives us 1,000th. So if I times not by 10 back in our original problem, but 10 to the power of minus 1, what are we really saying? Well, we're saying that times 10 to the power of minus 1 is like finding a tenth. It's like dividing by 10. It's the same as saying we're multiplying by a tenth. And multiplying by a tenth is going to make this number 10 times smaller. So we found what we're looking for. We want to times by powers of 10 that are negative. Let's put that in red. So let's just do it once. 2.13 times 10 to the power of minus 1 is effectively dividing by 10. It's finding a tenth of our original number. So we'll get 0.213, which is exactly what we wanted. Okay, now how many times will we need to do that? How many times 10 to the power of minus 1s will we need? Well, 2.13 times 10 to the power of minus 1 gives us 0.213. If we take 0.213 times 10 to the power of minus 1, and we'll get 0.0213. If we do it again, times 10 to the power of minus 1, again, let's put the start number, 0.0213, will give us 0.00213. 0.00, I should really be keeping these in place. They're going all higgledy-piggledy. 0.00213 times 10 to the minus 1 will give us 0.0000213. We've got one more to do. 0.00213 times 10 to the power of minus 1 finally will give us 0.0000213, which is our starting number. So what do we do to the 2.13? Well, we times by 10 to the minus 1. Let's go for different colour. 1, 2, 3, 4, 5 times. Let's go back. So what we've done is we've taken our 2.13 and we've multiplied by 10 to the power of minus 1 times 10 to the power of minus 1 times 10 to the power of minus 1 times 10 to the power of minus 1, I've lost track, 1, 2, 3, 4, 5, times 10, that's messy, go away, times 10 to the power of minus 1, we've got 5, times 10 to the power of minus 1, 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 times 10 to the power of minus 1. But we also know from our index laws that we can express that as 10 to the power of minus 5. Because our law for multiplying these is just that we can add these indices here. So we can add minus 1 and minus 1 and minus 1 and minus 1 and minus 1, and we get times 10 to the power of minus 5. So our final answer will be 2.13 times 10 to the power of minus 5. 0.000213 is equal to 2.13 times 10 to the power of minus 5 in standard form. So 0. That's 3. It really is. Okay, now there are lots and lots of ways to remember how many times, what power we need, lots of tricks, but I wanted to go through nice and slowly to show why this 0.000213 is equal to 2.13 times 10 to the power of minus 5. Okay, let's try one more number. Let's try 0.01302. How would we express that in standard form? Okay, well this time let's go a little bit quicker. Okay, these are the digits we need to take. We'll miss these leading zeros. We don't need those to recreate our starting number. We need 1, 3, 0, 2. 1302 is no good. It's clearly not a number that's greater than or equal to 1 or less than 10. But 1.302 is. So step 1 is to find my A, my starting number, my number in the first part of that standard form expression. So we've got 1.302. Now we need times 10 to some power. Now we should have already spotted this time we want a small number here. So we know we're going to get a negative power. All that's then left to work out is how many times did I move that decimal place. Well, in my 1.302, my decimal would be there. And this time it's jumped 1, 2 places. So 0.01302 is equal to 1.302 times 10 to the power of minus 2. Let's get rid of that. And can we get rid of that? Come back 3. Okay. Now, as I said, there are lots of ways to remember how what the power here is. Some people like to think it's the number of zeros including the one before the decimal point. So in other words, we've got 2 zeros here. Therefore, this will be minus 2. There are other ways that we can go through in class. Right, if that made some sort of sense, you know what's coming. Have a go at these. Could you express 0.000647 in standard form? And could you express 0.020? Shouldn't say 0 and then 0, should I? What shall we go for? 0.0220200 in standard form. Have fun?